two demos on either sides. One is for measuring total volatile organic compounds. It's an indoor air quality sensor. And then the other one is an outdoor air quality sensor, but could also be used in indoor environments because nitrogen dioxide and ozone are pollutants even in indoor environments. So this is basically an air quality environmental sensing demo platform. On my left side, you have this one here that's TVOC sensor. VOC is volatile organic compounds that's present in a lot of different contaminants that you can find in indoor environments. It could be in your cleaning agents, in alcohols, in formaldehyde, like refrigerant leaks. So there's a lot of different chemical pollutants that are present, and this sensor can pick that up, and it can do demand control ventilation for you. It can pull in outdoor air that is clean and filtered and blow it out and reduce the pollution levels in an indoor environment. These are necessary because we spend like more than 90% of the time in an indoor environment, so these sensors are vital. And some of these sensors have a strong odor, some of them don't have a strong odor, so your nose is not always a good indicator, so you need a supplement to it. You need a sensor to do this for you and make sure you're healthy. The spike here shows the time when I opened the alcohol bottle and just let it in there, and you can see the immediate reaction. I can show that to you again. Open this up here. And you start seeing an instant reaction to it, and I remove it. The unique thing about this sensor is we do an absolute calibration. We don't just tell you that, you know, this is the air quality went from bad to worse. We actually tell you what the baseline needs to be, and is it truly bad compared to good air, like true good air. And so not just like, you know, from your current environment to the next environment, is it just going from bad to worse? We're actually telling you that this is good according to a set baseline, and then bad according to another set baseline. So that's what we do with absolute measurements. And you can change it, by the way. We meet the different standards. You can change the different firmwares and apply it for different applications. So this one right here, it's an ozone sensor. That's what I'm running here. This is the sensor, and then what I've selected it for is to be selective to ozone, picking up ozone. I turn on the ozone generator here, and that's already tubed into this box, and as soon as I turn it on, you'll see the resistance starts to rise. That's the raw resistance data, and this is the calibrated output, and you see the calibrated output is also going up. But it can also pick up nitrogen dioxide, which is another contaminant you'll find in outdoor environments. So these are all chemical contaminants you'll find in outdoor environments, but they do make their way indoors when you do ventilation, right? You're pulling in outdoor air essentially, and you don't have a good filter. You're not having an activated carbon filter that filters out these chemical pollutants. In that case, they still make their way indoors, and you need to monitor it and make sure you're not pulling in outdoor air when it's contaminated. And then when I turn it off, it's like eventually going down. So you're gonna see a spike. So that's when I turn on the ozone generator, it started going up, and then it's gonna come down. So that's essentially what we're showing here.